Hello again, this is Valentine from Simplistic, and out here we're going to consider a reaction given to us out here, and we have to calculate the delta G naught for the reaction at 25 degrees Celsius using this relationship out here. And then after that, we have to determine whether the reaction is spontaneous at standard conditions. So to use this relationship, we need to first figure out the delta H naught of the reaction and then the delta S naught for the reaction. So for that, we need to go to our table of thermodynamic values and pull the numbers for NO, O2, and NO2. So let's go ahead and do that. So I have gone ahead and already found the table and pulled the values. So if I put a reactant or product out here and the values that correspond to them, delta H naught formation, that's what we're going to pull from the table. Delta H naught is given to us in kilojoules per mole, and then S naught, which is given to us in joules per mole Kelvin. All right, so for NO2 we have 33.2 for delta H naught and 240.1 for S naught. For NO we have 91.3 for H naught and 210.8 for S naught. And for O2 we have 0 for H naught and 205.2 for S naught. Okay, so the first thing we're going to do is use the values of H naught to calculate delta H of the reaction. So that is given by this formula. Let me use a different color. Delta H naught of the reaction is equal to summation NP delta HF naught of the products minus summation NR delta HR naught, F naught of the reactants. And what this means is we're essentially going to find the delta H of the product and multiply it with the coefficient, and then we're going to subtract the delta H of each of the reactants added together multiplied by their respective coefficients. So let's go ahead and assemble this. So for the product, since we have only one product, the delta H for that is given out here, 33.2. Let me go ahead and write that properly, 33.2. So that's going to be 33.2 minus, and then for the reactants, we have delta H is 91.3 for an NO, and we're going to add the oxygen to it, but since oxygen has half in front of it, we're going to multiply it by half, so half times 0 for oxygen. And simplifying this, we get 33.2 minus 91.3, which is equal to negative 58.1 kilojoules per mole. Okay, so now the next step is to find the delta S naught of the reaction using the values of S naught. So the formula is very similar to delta H of the reaction. So delta S naught of the reaction is equal to summation of NP S naught of products minus summation NR S naught of reactants. All right, so similar story out here. We're going to find the S naught of the product multiplied by the coefficient and subtract the S naught of each of the reactants multiplied by their respective coefficient. So let's pull those values from the table. So that's going to be 240.1 for NO2 and minus, it's going to be 210.8 for NO plus half of the oxygen is going to be 205.2. All right, simplifying this, we have 240.1 minus 210.8 plus 102.6, which is equal to minus 73.3 joules per Kelvin per mole. All right, so now we have both of these. So we're going to put this all together in this equation. Now, since we're solving for delta G naught of the reaction, we just have, and we know this and this, we have to find the temperature, which actually happens to be sitting out here. Now, since you have Kelvin out here, the temperature 25 has to be converted to Kelvin. So temperature, we're going to write that as is the same as 25 plus 273, which gives us 298 Kelvin. All right, so let's plug that in to this equation. So delta G naught of the reaction is equal to minus 58.1 kilojoule per mole minus 298 Kelvin times negative 73.3 joules per Kelvin per mole. Okay, now one thing to notice out here, notice carefully how you have joules out here, but you have kilojoules out here, which means we have to change this to joules. So we have to multiply by 1,000. So minus 58,100 joules per mole. That's what it becomes. And then the right hand side simplifies to, if you kind of multiply these terms out, you get plus 21,843.4 joules per mole. And now we can just simplify that to minus 36,256.6 joules per mole, which simplifies to minus 36.3 kilojoules per mole. And there you have it. That is the delta G naught of the reaction. So the next part of the question is we have to determine whether the reaction is spontaneous at standard conditions. Turns out if delta G naught is a negative number like we have out here, then it is indeed spontaneous. All right, I hope that made sense. Thank you for watching.